Hello student. So we are at model 8 chemical transformation. So we are in the fifth functional element transformation. So in the previous class I talked about whether waste could be useful as an fuel. So you got the idea about whether the waste could be possible to use as fuel. Again depend upon the different parameter and especially on calorific value. So today we will talk about incineration, now proper combustion process. So what is the meaning of incineration? Like incineration is a waste treatment process that involves combustion of the waste at very high temperature in the presence of oxygen. Okay, that is the incineration process. We can call as an combustion also the similar way, and the resulted the production of ash, that solid residue will produce after the combustion or incineration process. Flue gases, the gases will produce, we called as in flue gas is very polluted gas is producing, and along with that, because it is a combustion process, the heat also will get produced from the incineration or combustion process. So incineration is a feasible technology for combustion of segregated waste, as I already told in the previous class also. If you have a segregated waste, especially onto the sources, the dry percentage, dry waste is very good for the incineration process, especially the paper, plastic, which is a highly combustible matter and will get very high calorific value, that is possible to use for the incineration process. And this is the one of the very best technology to reduce the volume, because this solid water I was talking about, to that ash percentage is very low, that 5%, maximum 10%, not more than that will be get produced. So means volume reduction is 90 to 95% volume reduction is possible from this technology. The potential of for the energy generation, because the energy also, that heat we can convert into the power or energy production out of that, is depend upon the composition, density, moisture content, and different parameters also you saw that, especially onto the volatile solids. If more organic content or volatile solids are more, then the energy production will be very high. About 65 to 80% of the energy content of organic matter can be recovered as heat energy from the incineration process, which can directly use as a thermal application for producing power or steam turbine generation. So, I will talk about that. We will get three different products. Heat will be the first product, from that steam we can produce, and from that power we can produce. As I was talking about, incineration is help to reduce the landfill volume. Obviously, the volume reduction is more in this case. So, whatever the waste is reaching to the disposal site or landfill site, there also at least that landfill site can work for the more time. Incineration is a feasible when there are no better options of processing of waste, shortage of land for landfilling. So, this is very important point. There is no, if there is no better option is available. So, what could be the better option for the this dry waste, which is also combustible waste? The better option is a recycling, which we talked in the few last module. Recycling is the better process, because there need not to worry about the flue gas or whatever ash is producing, and we do not have much energy. There is no need of temperature, this very high temperature combustion process in the recycling process, that is the better process. Or some not recycling, but reuse also could be possible of that matters, that is also better option. If those kind of options are not available, then the incineration is one of the very important technology or better option. And also there is a shortage of land, like there is one example is given, like Japan is very small country, the land availability is very low, very small land available. So, such kind of countries cannot depend upon the to find the land filling of the such kind of waste. So, this technology is better option for the such kind of country. On the downside, incineration is a expensive process, and ash remaining after the process completion can be harmful is not only the ash, but also the flue gas is producing. We need lot of treatment processes to treat the ash also, and the what flue gas is producing during the incineration process. Now, the incineration process, what exactly is the incineration process? In the brief, in the furnace the combustible components react with oxygen on the combustion air, release a significant amount of hot combustion gas. That combustion gas normally we called as an flue gas. The moisture content of the waste is evaporated in the initial stage of the incineration process, and then the combustible matter will get combusted. So, the furnace is designed in such a way that initially when the waste is received in the incineration process, first moisture will get removed and finally the combustion process will get start, and because of that ash will get produced, and could be possible that uncombustible matter could be possible, that will also come out into the solid residue. Through incineration, the solid constituents of the waste undergo a range of process, the result of exposure to heat and contact with the combustion air. So, whatever the solids, I think that dry matters were putting into the incineration process or in the furnace, that will go a range of processes, okay, the combustion processes. Then the combustion gas pass from the furnace to the after burning chamber. Again it will get after burning process, and from that we can produce heat, and because of that heat we can convert into the steam, and that steam we can produce power from that particular combustion gas. In the European Union, the minimum temperature of 850 degree centigrade for the municipal waste and 1100 degree centigrade for certain type of hazardous waste. That is for the complete burnout of the combustion gases in the after burning chamber. So, you see that I think European Union was the first, I can say is this union or the countries under the European Union, they finalized the temperature 850 degree centigrade in the first chamber, the first furnace chamber, and after burning process of this combustion gas the temperature has finalized 1100 degree centigrade, and this temperature should be maintained for minimum time of 2 seconds as measured from the last injection of combustion air. So, that is the that first time the European Union come up with the such kind of standardization of the furnace temperature. I think lot of country like India also come up with some kind of legislation, which I am going to show it here. This EU has strict legislation as to no feeding into the incineration before attainment of required temperature. See here I think they made it a very strict legislation, no feeding if we are not attaining the required temperature. That is the important one. If we are not getting temperature at 850 degree centigrade, we can't feed that kind of waste into the furnace process. And now, because we have also the solid waste manual 2016 also, now India also come up with this kind of standardization. The minimum gas phase combustion temperature same, the 850 degree centigrade for MSW, and minimum residence time of the flue gas is above the temperature 2 seconds after the last incineration, air supply should be followed. So, I think this standardization also come up. I will give few more standardization or suggestion by the solid waste manual of 2016, if you are try to install some kind of incineration plants in India, for especially for the MSW. Now, before going to the incineration process, I thought of to show you some brief history about the incineration process. So, the first incineration developed in the UK in 19th century is very old method, because problem was especially all European countries and especially UK, the land availability was very low, and because they started industrialization 100 years before. So, and these industries did not had the proper treatment process for their solid residues. not for polluted water also, wastewater, and not for the solids also. What and most of the waste I think they are able to combust it. So, that was the idea behind the starting the incineration in the 19th century in the European countries. And waste incineration plant treat waste of great variation in the compositions. Obviously, in those days 100 years or 50 years before, in the European countries also the compositions was very large variation used to be get it. And this is one of the technology of incineration process. We are also going to talk about moving rate technology was developed in 1920s and 30s and developed as a combination of grate with rotary kiln. This is another technology. Okay. Normally, we can find the this rotary kiln after the moving rate technology. So, both the technologies together, which I am also going to talk in the next lecture. So, this is very old technology. See, idea of sharing this brief history, because we have lot of literature available, that is the idea. If more literatures are available means we have lot of data available with us. So, data means I think wherever, I think if you are planning to have the incineration facilities, I think if those kind of data and literatures available, so easy to get install the incineration facilities in any country. And this is one of the flue gas treatment technology, electrostatic precipitator. So, this also I will going to talk into the next lecture when you will talk about the cleaning of or treatment of flue gases. I think see the started in 1920 and 30 and this technology has come up in 1970s, 80s. So, until there was no proper treatment. This is one of the very important technology to treat the solid concentration in the flue gas, or especially we can say dust. These very small particles of the dust also can be removed from the flue gas, and the flue gas is very highly temperature gas. Temperature goes up to 800, 600 degree temperature, and from that dust is getting removed by this kind of technology. In 1989, the European Union come up with this kind of directive, which I think in the last slide I showed it, 850 degree centigrade with 2-second residence time. Okay. In 1989. Now, we will talk about the combustion technology. So, combustion system is commonly referred as a heat of an incineration plant, that is a combustion system. The combustion system can be classified in the two different type. First is the mass burning of the non-homogeneous waste. So, it is a simple combustion, mass burning, complete burning, and especially for non-homogeneous waste. And we are also especially in the developing country like India, we are getting lot of non-homogeneous kind of waste, means lot of heterogeneity in the waste. So, such kind of technology combustion system could be possible to use by our country also. So, this is moving rate technology, and another is a burning of homogeneous waste of limited particle size. So, this is another technology which also we are going to talk about, fluidized bed incineration plant. This is specially for the homogeneous waste and limited particle size, particular size is required. Normally, such kind of technology is not that beneficial for the MSW, but I think we need to know that if suppose we are planning for very special kind of waste like sewage sludge, like even plastic itself alone. So, such kind of technology could be possible to use. Now, I think before incineration, especially the India, we required pre-treatment of waste or pre-treatment of the dry components of the waste. So, depending on the quality of waste, the incineration system, some pre-treatment technology may be necessary, which involves sorting and homogenization of the waste before incineration. That was the idea behind the pre-treatment, that sorting means contaminants or non-combustible matters will be removed out or sort it out from that particular material and try to make it the homogenize the material, at least not homogenize in the type of waste or composition of waste, at least the size could be same. So, that combustion will be somewhat more beneficial. So, mass burning incineration or technology, the pre-treatments are removal of shading of bulky or heavy items. The large size item also is difficult to get burned out, complete burned out into the furnace. So, these bulky items or heavy items will be get removed out and mixing of low end high heating value waste. So, this is also one very important idea of pre-treatment, because if you see that the waste is collecting from the different locations from the city and the different vehicles are coming to the incineration facility. So, it is possible that sometimes the vehicle coming with the low calorific value of waste and sometimes it is possible the very high calorific value of waste is coming to the incineration facility. So, I think this is also one of the very good idea, if you can mix the both kind of waste. So, we will get proper temperature into the furnace, that is the what our standards to maintain the temperature of 850 degree centigrade. For homogeneous waste pre-treatments are, so this is for the second combustion system facility. The pre-treatments are required shading for homogeneous of waste, screening of narrowing of the particle range to the fluidized bed. Narrowing means the small size making for the fluidized bed technology and removal of metallic iron with magnet. So, because especially not only metal, but glass also has to be removed out from this technology. Suppose from the mass burning incineration the metal item or glass items is not getting sorted out. So, those are not combustible item, that will come out into the solid residue, but that will not create any problem into the furnace. So, now we will go for types of incinerations. Okay. There are three different types of incineration. So, first is the moving rate incinerator. So, this is the very simple incineration facility, is very well known technology. I think similar kind of technology we can get it into the core power plants also similar. The here in the inside furnace you will find the grate. I will show you some of the photographs and some pictures of the grate. So, you can understand. The conventional mass burn incineration based on the moving rates consists of a layered burning of the waste on the grate that transport the waste through a furnace. So, you see is a layered burning of the waste on the grate. So, the combustion will be onto the grate and then this grate will transport the waste through the furnace for the entire furnace. Now, this is the line diagram. So, you can see here solid refuse is coming to the storage hopper and this is the overhead crane. Through this crane the waste is feeding into the incineration furnace facility. So, this is the furnace and these are the grate, this is one grate, this is the other grate. So, this is for drying one and fan is provided in the bottom of the grate, so that the air could supply into the furnace. So, here waste is getting combusted and finally, this solid residue will come up. This is the second combustion chamber, okay, or that whatever combustion gases are producing, that is getting combusted into the combustion chamber, and after the second combustion chamber the gas will go through the gas cleaning arrangement. So, here flue gas treatment facility and finally, it goes to the atmosphere through the stack. So, here it is written the overhead crane feed the waste into the hopper, where it is transported via the chute to the grate into the furnace. On the grate the waste is dried and then burned at high temperature while air is supplied. Now, the ash including non-combustible waste fraction leaves the grate via the ash chute as slag or bottom ash. So, this is what the bottom ash, this is another ash very small particle size of the ash will also produce through the grate. Once we will talk about the solid residue, I will explain properly. And here also even in the flue gas cleaning treatment facility, a lot of fly ash will get produced into these treatment facilities. And the bottom ash or slag drop from the end of the grate into the water trap of the slag pusher. So, this is a slag pusher, here this is a simple water tank. So, whatever the bottom ash or ash is produced, that is going into the water, okay, because it is a very fine particle. So, for storage, and from that there will be a slag pusher, this tank will get removed out once it is get filled up completely. Then another tank is getting provided into the same facility or same area. The slag is cooled by the contact with water, and large piston pushes the slag to the conveying system. The amount of slag, this is the bottom ash or slag, usually is 10 to 25% by weight of the waste feed depending on to the waste composition. So, you see here 10 to 25% slag will get produced by weight. Then the fine particle and materials with low melting point may drop through the narrow gaps between the elements of the grate. What I was talking about, from these also the very fine materials, fine particles or fine ash is getting produced, and that is also producing 1 to 5% of the total amount of ash production. The flue gas from the furnace consists of minor part of the ash. From this flue gas also the fly ash will get generated. The flue gas constitutes about 5 to 10% of the total ash content. Now, what are the advantage and disadvantage of moving grate system? The advantage is can accommodate large variation in the waste composition and in heating value. So, what I was sharing about this technology is highly beneficial for the large variation of the waste composition, also variation in the heating value, and different calorific value mixes could be possible to get combusted into this technology, and can built in a large unit, that up to 50 tons per hour capacity. So, that is what I think this technology is very well known into the coal power plants. But the disadvantage, another I think advantage here, because lot of literature available, that is also another advantage, and number of countries has installed this kind of technology. So, when any new country is like India is trying to have such kind of incineration facility, we can get lot of literature, especially we can look onto the failure of the such kind of incineration facilities. And disadvantage is plant installation cost is very high and maintenance cost is also relatively high. That is the major problem of these technologies. Is all incineration facility, combustion facility require lot of money, not only for the capital cost, but also maintenance cost is very high. So, because of that only, if you are planning for incineration facility and we are not planning for getting any power production or any kind of product from the such kind of facility, so it will be very costly process. So, most of the cases or most of the country, when they tried incineration facility, not only for the volume reduction, but also to get some kind of product out of that. So, from this product could be a heat, this product could be a steam, this product could be a power. From that at least we can get some kind of maintenance cost, we can get it out from the by selling of such products. Now, next technology is the rotary kiln incineration. So, you see here this is the rotary kiln, and finally, after incineration bottom ash is getting produced and the flue gas is coming out. The mass burning incineration based on the rotary kiln consists of a layered burning of waste in a rotating cylinder. The material is transported through a furnace by the rotation of the inclined cylinder. So, this is the cylinder is getting rotated. The rotary kiln usually refractory lined, but can also be equipped with a water walls. So, these are the refractories or water walls. The diameter of the cylinder may be 1 to 5 meter and the length could be 8 to 20 meter. So, this is one of the rotary kiln. You can see here, this is the rotary kiln. The capacity would be within the range of 2.4 tons per day to 480 tons per day or 0.1 tons per hour to 20 tons per hour waste production. The kiln rotates with a speed of typically 3 to 5 rotations per hour. The rotation is not that fast. The excess air ratio is well above that of moving grade insulation and the fluidized bed. The fluidized bed insulation is a third type of insulation type. So, the excess air ratio is required, means more amount of air will be supplied for the combustion process. So, this is another insulation facility. This is from the China. Rotary kiln combustion facility. The energy efficiency does not exceed 80%, that is I think is okay, but still is acceptable. So, as the retention time of the flue gas usually is too short for complete reaction to take place in the rotary kiln itself. The cylinder is followed by an after burning chamber which may be incorporated in the first part of the boiler. So, that is one of the very important point for the rotary kiln, because combustion time or retention time of the waste into the rotary cylinder is short for complete combustion of the entire waste. So, if you are providing some after burning chamber, that is more beneficial. So, because of that only rotary kiln may be used as a combination with the moving grate, where the moving grate form the ignition part and the rotary kiln form the burning out station. Means I think this is the one of the very good idea about combination of the two technology. The first technology for the first combustion or the incineration of the material, solid material will be inside the moving grate furnace, and the whatever the combustible gas is coming out or combustion gas is getting combusted into the rotary kiln. So, I think because in the moving grate also you will be required second combustion chambers is required. This combustion chamber could be rotary kiln system could be possible. So, this is another photograph of rotary kiln. This is in Haryana, India, rotary kiln incineration facility. This is another from the Saudi Arabia. Now, advantage, disadvantage. Advantages are mostly similar to the moving grate incineration. Energy efficiency is somewhat lower than the moving grate incineration. Disadvantage is same way like moving grate system, the installation and maintenance cost is relatively higher, and rotary kiln may be rarely used for the new MSW incineration plant with high heating value waste. I think this kind of rotary kiln is good to use as an second combustion chamber for the combustion air, which will have low heating value. Now, next is the fluidized bed incineration. So, as the name suggested, fluidized bed. So, inside incineration there will be a bed which will get fluidized and the entire waste also in the fluidized condition. So, here is the line diagram of that. First I will explain the line diagram. So, here waste is getting fed into the vertical chamber. Now, here this is the fluidized bed, and from that bottom the air is added, and whatever the waste is added into the or getting fed into the chamber, the waste will be in the fluidized condition because air is getting supplied. So, this is your combustion chamber, and whatever the gas will come out, that will come out as an flue gas form. and there is facility for putting some additional fuel for the combustion to increase the efficiency of the combustion. The initiation works on the principle where solid particles mix with the fuel are fluidized by air. By fluidization, the fuel and solids are suspended in a upward air stream, thereby behaving like a fluid. See, is the fuel and solids. These entire solids will be suspended in the upward air stream. The reactor usually consists of a vertical refractory lined steel vessel containing a bed of granular material like silica sand, limestone or some kind of ceramic materials. This is the bed of granular material. The fluidization of the bed is ensured by air injection through a large number of nozzles in the bottom of incineration, causing a vigorous agitation of the bed material, in which the incineration of waste take place in a close contact with the bed material and combustion air, allowing relatively low excess air travel and high thermal efficiency up to 90%. So, here the small nozzles will be available from the air is getting supplied. So, that the entire solid material will be into the suspended phase. So, suspended phase means entire area of the material is available for the combustion. So, because of that the thermal efficiency is very high into this kind of technology. This is one of the initiation bed, you can see here. This is a vertical vessel in Japan. This is in USA, fluidized bed incineration facility. I think this kind of technology never has been used for the MSW, but special kind of material, because this kind of technology required very special kind of material, means I think this technology required the homogeneous kind of material. So, in Japan or USA they use this kind of technology especially for the special agriculture residues that is more homogeneous in nature, or in the municipal area sewage sludge, dry sewage sludge is highly combustible, and because these kind of countries are very developed countries, and these countries are having the large number of sewage treatment facility, and because of that large amount of sewage sludge is getting produced. So, this kind of technology is very useful, because that material should be fluidized with the air. So, mean understand that this kind of technology cannot be used for the very large particle first thing, and not heavy particles also we can put it into the such kind of combustion facilities. Now, advantage, there are a lot of advantages of that, very beneficial of this technology I think is noted, and especially the NOx generation like NO2, NO3 or NO production is low as compared to the both the technology. That is the major problem with the moving rate and rotary kiln facility, and even capital and maintenance cost are also relatively low. And disadvantage, I put it into the disadvantage, but that is a prerequisite of fluidized bed incineration facility, depending pre-treatment are required for the smooth functioning. So, that is the, I think I put it in the disadvantages, but that is a prerequisite for the such kind of technology. Primary useful for homogeneous waste type, which include liquid waste also, because that will also could be fluidized into the air. Now, moving grate incineration plant design and layout. The grate has two principles. This is the major design point or design idea behind the moving grate incineration facility, that is the grate. So, grate has two basic principal purposes: transportation, mixing and leveling of fuel or waste, okay, and supply and distribution of primary combustion air to the layer of waste. That is the two major principles of the grate. First is the transportation or mixing or leveling of that particular waste material into the furnace area, and supply and distribution of primary combustion air to the layer of the waste. So, that the proper combustion could be possible. Various grade designs are available characterized by their respective principle of fuel transportation as shown in the upcoming figure. So, these are the different kind of moving grates. So, this is the grate, okay. This is the forward pushing grate. You can see here, this is the one kind of grate, this is reverse grate, this is going upward, this is fixed. So, similar way horizontal grate, this is rotary one. So, here the rotors are there, and from that primary air combustion air is adding through the small nozzles from the grate, and waste is getting transported and also getting combusted also. This is another rocking grate. So, there are different kind of grates available, and I think number of different private companies also install the combustion facilities by using the different kind of grates. Grate important parameter, the grate length, maximum of 65 to 70% of grate length is supplied as a drying and combustion zone when operated in the design point at nominal load. So, maximum of 65 to 70% of grate length is applied as a drying and combustion zone, okay, of that 100% of grate length. Remaining length should be available to ensure the final combustion and complete burnout of the slag and ash. That is the very good idea about to finalize the proper length of the grate. So, that 65 to 70%, that means 2/3 of area is required for proper combustion, remaining the 1/3 area will ensure the final combustion of complete burnout of the remaining material. Grate air supply, the high variation in the load and heating value requires a very flexible primary air supply system in respect to the both amount supplied and the supply spots. The primary combustion air should be supplied to the waste layer through a small slots in the front side of the grate bars or through, this is the size of the slot or that opening 1 to 2 mm between the grate bars. And air supply area should be maximum of 1.5 to 2% of the total grate area to ensure satisfactory air distribution. And air supply through the slot, that is 10 to 15 meter per second, the velocity of that particular air supply through the grate into the waste. Now, about the furnace, the design in such a way that long retention and reaction time of the flue gas at high temperature is ensured. The furnace temperature usually as the interval of 1000 to 1200 degree centigrade, but I think minimum temperature in the first combustion chamber has to be maintained 850 degree centigrade, and second combustion chamber around 1100 degree centigrade temperature has to be maintained into the furnace. Flue gas velocity in the furnace is maintained at a level lower than 3.5 to 4 meter per second, whatever the flue gas is generating into the furnace. And furnace section depend on the flue gas flow directions. So, this is the combustion chamber. So, this is the one way of flue gas flow direction, this is the counter flow and this is the mid flow. Here we are not going to discuss much onto the furnace design and all, because already told that this course is for the environmental engineers. So, we will just talk about the what kind of flue gas will produce and how best we can treat that particular flue gas. This is one slide I put it specially because many countries are utilizing such kind of facility, because for combustion will be required a large amount of primary air. So, can it possible that flue gas, because already heat is there in the flue gas, can that flue gas can be used for the primary air, not 100%, but at least 5%, 10%, 50%, these flue gas can be recycled or recirculation could be possible into the furnace. After the dust filter, part of the flue gas, that 20 to 30% may be extracted and returned to the furnace. Flue gas recirculation is operated as well as economic environmental advantages, such as because recirculation of flue gas can lead to the higher thermal efficiency, okay, because already the efficiency can excess up to 1 to 3% may be achieved, because already this flue gas will have the temperature with that particular gas. And reduction of NOx formation, this is one of the very important benefit, that 20 to 40% with 20 to 30% of flue gas recirculation, 20 to 40% reduction could be possible into the for the NOx formation. Reduction of the amount of flue gas entering the flue gas cleaning system. So, obviously, the amount reaching to the flue gas treatment facility will also get reduced. Now, the energy recovery system, the energy released from the incineration leaves the furnace with the flue gas at a temperature of approximately 1000 to 1200 degree centigrade. See the temperature of the flue gas. The hot flue gases are cooled using the boiler before passing on to the flue gas cleaning system. In the boiler, the energy released from the incineration is recovered as hot water or steam, depending on the type of the boiler. Okay. And the steam thus could be used to generate power. So, we will get three different products. The first is the heat, this heat will get produced, and next steam will get produced, hot water or steam, and from this steam we can generate power of that, power from the energy recovery. So, heat, steam and power, there are three different products will come up. Normally, when you talk about waste to energy facility, waste to energy, people will think that energy means power. So, is not that key is not only that energy is a power, but energy could be heat, energy could be steam and energy could be power also. So, there is a possibility that number of companies, especially food processing industries or metal industries required lot of heat, or some industries required steam. So, rather than producing power directly, why not this heat is getting directly supplied to the such industries, and why not the steam is getting supplied to the food processing industry, which is required steam. So, in developing countries what they did, they installed the incineration facility in such locations where these kind of industry is available. So, rather than power production, because the efficiency of power production is very low, very poor. So, why not these kind of two products, either heat or steam, getting supplied to the such industries. So, this is one very important table which summarize the typical efficiency in the different energy recovery system. Suppose if you are planning for power production only from the waste to energy plant or incineration facility, and power production is only the 25 to 35% recovery, and the efficiency is only 25 to 35%. So, you can understand if you are planning only for the power production is not that beneficial, but if you compare with steam and power production, the efficiency goes to 75 to 90%, and especially when you are planning for heat and power, combination of heat and power, then see the efficiency 80 to 92% efficiency could possible. But in this case also the power efficiency is low, but the heat efficiency you see 60 to 65%. So, there is always beneficial to plan or to install the incineration facility for planning of not only production of power, but also plan it either steam or heat along with the power production. So, here I come up with the one slide just to explain India's first waste incineration plant. In 1987, the Ministry of Non-Conventional Energy Sources (MNES), they commissioned Timarpur Refuse Incineration cum Power Generation Station in the Timarpur in Delhi, and at a capital cost of 20 crores. So, you can see that in 1987 the cost was 20 crores, the capital cost, and that particular technology has come up from the Denmark. The plant was designed to incinerate 300 tons MSW per day to generate 3.5 megawatt of electricity. The plant was shut down after just 21 days trial. Trial was failed, and after that has shut down the complete incineration facility because of poor quality of incoming waste. See, in 1987, 1990, even up to 2000, if you see the waste composition, I showed it in the previous lectures, the composition of Indian waste was mostly the biological in nature. And those days, the biological components used to be a 60 to 70%, and everything was the mixed, there was no segregation, and because of that very poor quality of incoming waste used to be received into this incineration facility. Calorific value of the supplied waste was in the range of only 600 to 700 kilocalorie per kg, but required was calorific value was around 1500 kilocalorie per kg, the required calorific value. Attempt to supplement the combustion with a diesel fuel. Diesel fuel, even coal also has been added to get the proper combustion temperature, but finally they put a lot of money for maintenance and running of that particular plant. Finally, the project was officially shut down in July 1990. So, within 2-3 years that completely shut down. I think I will come up with a few more case studies in the last lecture of the incineration. So, because recently we have come up with some more incineration facility in India, and even I think we need to know some of the case studies about the European incineration facility, especially Japan is good for the into the incineration facilities. So, I think one of the case studies will come up with in one of the lecture. So, I think here I come up with 2 slides, the last 2 slides on few consideration for installation of MSW incineration plant in India. I think incineration is most relevant for the dry bin content in 2 bin system. So, that is from the manual 2016. Pre-treatment is necessary for unsegregated waste, but I think if it is already segregated at source, no need of pre-treatment. Lower calorific value, see the 1450 kilocalorie per kg throughout all the season. So, that is the important consideration. So, all the seasons, especially in the rainy season, also need to have this kind of calorific value, and that is lower calorific value, okay, or net calorific value. Annual, that must not be less than 1700 kilocalorie per kg, annual average. The furnace must be designed with best available technology to ensure stable continuous operation and complete burnout of the waste and flue gas. Segregated waste supply should be stable amount at least 500 tons per day. See, the segregated waste supply should be 500 tons per day capacity. I think only the city is having large amount of waste generation. So, suppose the cities like Kolkata, Delhi, Mumbai, Hyderabad, Bangalore, Jaipur, such kind of cities which are producing 2000 tons per day waste or more than that. So, such kind of cities only can come up with such large incineration facility. Skilled staff is also required, that is also very important point. Since capital investment is high, so planning horizon should be 25 years operation or more is required to before planning for installation of incineration facility, and a strict monitoring system should be followed. This is especially for the flue gas monitoring system. And few consideration for MSW, another, once you have installed the incineration plant, for the operation purpose, what are the consideration need to be followed. That minimum temperature which I already talked about, 850 degree centigrade with residence time of 2 seconds, optimum oxygen content, should be maintained for the combustion. Carbon monoxide content of flue gas is a key indicator of the quality of the combustion. This is properly for the monitoring system. The flue ash acts as a catalyst for particular synthesis of this is the important pollutant dioxin and furans. That standardization also has been given now in the monitoring system. This has to be monitored, how much is the production of dioxins and furans. And in order to reduce the formation of dioxins and furans, the flue gas temperature has to be reach about 200 to 450 degree centigrade, means cooling of the flue gas is very important for the reduction of dioxins and furnaces. So, these are few consideration is given in the MSW manual, and here we will finish this lecture. Now, I think once you understand the entire incineration facility, now there are two major pollutants are coming out from the incineration one, which as an environmental engineer we need to understand. One is the flue gas and solid residue. So, in the next lecture we will go for flue gas treatment, how best we can treat the flue gas, and followed by solid residue. Also, I think in one of the lecture I will talk about few case studies also, so that you people can understand proper incineration or chemical transformation of MSW. Thank you.